Hey everyone! Well, here's our first of hopefully many more to come integration videos. And we're going to look at the integral of secant x dx. So what that means is, well, an integral is a antiderivative. So we want to find the function of x, right? When you take the derivative, you get secant. Well, what is that? I know that the derivative of tangent x is secant squared x. So if we had the integral of secant squared x dx, well, that'd be pretty easy. That would just be tangent. But what about the integral of secant? Well, I know I could write secant as 1 over cosine. But would that help at all? I'm not sure. But I think a better way to go about this might be to multiply by 1. I mean, if you multiply by 1, you're not going to change anything, right? But we got to do it in a pretty slick, kind of creative way. How about we try to multiply this integral by, let's multiply this by secant x plus tangent x, and then all over the same thing, all over itself, secant x plus tangent x. So we're multiplying here by 1, right? I mean, this is something over itself. That's going to be 1. Okay, but why would I want to do this? Well, let's see. So what do we get here? We get the integral of, well, we distribute the secant. So we get secant times secant would be secant squared, we write it like that. Secant squared x plus what? Secant times tangent. So that's secant x times tangent x. Okay, and that is all over secant x plus tangent x. And don't forget your dx. Okay, so we started out with the integral of secant x dx. And I'm claiming that this crazy integral, secant squared x plus secant x tangent x all over secant x plus tangent x, is somehow simpler than just the integral of secant. Well, how can that be? Well, can we make some kind of substitution? If you make this, I mean, when you're doing integrals, one of the best and first things you're going to always try and do is try to do a substitution. Sometimes they call it a u, or a du to du substitution. Because normally we use u as our variable. We're going to change the x's into u's. But what do we want to let u equal? Well, let's say we try to let it equal this bottom part, secant x plus tangent x. Okay, so if that's u, then we always have to find, we have to change now, if we have a u and we have x's and we're integrating with respect to x, that's not going to work. We have to have, if we're integrating with respect to whatever, we have to have our variables all the same. And to do that, we're going to take du. We always got to find du. So if u equals this, du would just be the derivative of u. So what's the derivative of secant x plus tangent x? Well, the derivative of secant, you can always look up if you don't know it. It's secant x tangent x. And then plus, well, the integral of tangent is secant squared x. And then we got dx. Okay. Wow. Well, take a look at what we have here. And then look at our numerator. It's exactly, while the terms are swapped, right? We have one term here and one term here. But when you're adding is commutative, right? We can add in any order we want. So we can flop this and we have the exact same thing. We have secant x tangent x plus secant squared x dx And that whole thing is du. So if we can take this integral and we can write this whole top part as just du. Or we can write a 1 times du. We could write it as 1 over this bottom, secant x plus tangent x. Well, that we called u. du, right? It's just du over u. Or 1 over u. Same way. If you want to write this as du over u, that's fine. I like 1 over u because I see 1 over u, and I know that integral of 1 over u is the natural log of the absolute value of u. Plus c, of course. Right? So, we just found this integral, which is this integral, which is this integral we started with. Well, okay. So, this integral, this equals what? It equals the natural log of the absolute value of u. But what is u? Right? We started with x, so we better finish in x. You don't want to finish in u, because what is u? U is secant x plus tangent x. So it's the natural log of secant x plus tangent x plus c. And there is the integral of secant x. So now I'm probably going to stop right here and then make a video pretty soon where we look at the integral of secant cubed. And how would that look and what's all involved with that one? I'll see you soon. Bye.